Hello everyone and welcome to the last video on functions. In this particular video, we are going to have a look at recursion. Now before moving on to the technical aspect of what recursion is, when do we use recursion, and some of the applications of recursion along with its advantages and disadvantages, let us first just have a glimpse about what is recursion in English grammar. I know that this is not a part of the syllabus, but then there's nothing wrong in having some extra information with us always. Recursion is the repeated sequential use of a particular type of linguistic element or grammatical structure. Also, it is called as linguistic recursion. Recursion has also been described more simply as the ability to place one component inside another component of the same kind. Have a look at this particular slide which is there in front of you. I repeat, it is simply an ability to place one component inside another component of the same kind. A linguistic element or grammatical structure that can be used repeatedly in a sequence is actually said to be recursive. Then the question that comes in my mind is, why do we need recursion? Recursion is made for solving problems that can be broken down into smaller repetitive problems. It is especially good for working on things that have been possible branches and are too complex for an iterative approach. Now let us look at the technical definition of recursion. Just try to recollect, we had seen the varieties of user-defined functions where one function was calling another function, the first function was calling second, the first was calling third, the first was calling fourth, and so on. We moved on to see function 1 calling function 2, function 2 calling function 3, and so on. But we have never come across so far where we said that function 1 is calling function 1 again. Now that is what is recursion. In simple terms, ability of a function to call itself is called as recursion. It is also called as circular definition. Now when we look at the process of recursion, right, it actually refers to the process where a function can call itself either directly or indirectly. That means what? Recursion is broadly classified into two types. The first one is direct recursion and the second one is indirect recursion. Let us have a look at both of this. The first one is direct recursion. What it means? When in the body of a function there is a call to the same function, we say that the function is directly recursive. That means direct recursion occurs when a function invokes itself. Have a look at this code. I have a function whose name is num, right? The function name is num, and I have a couple of lines getting executed, and then somewhere here I'm trying to call the same function again, right? So within this particular function definition, I'm calling the same function again. That is what we say direct recursion. Means what? In the body of the function, there is a call to the same function. You look at this, num and num. So it is actually call to the same function, which tells me it's an example of direct recursion. Let us move into indirect recursion. Indirect recursion occurs when a function invokes another function, eventually resulting in the original function being invoked again. Have a look at this. Now I have the first function definition, that is num, and then I have another function definition called as sum. Now when I look at this function definition num, I have a couple of lines that is going to be executed, that is no doubt about it. I'm calling a function called as sum. So the control from this sum will branch to this particular place, and then it will have its own set of lines to be executed, and then you are calling the function num here. That means you are again going back here, correct? So num is calling sum is calling num. Again, num is calling sum, and sum is calling num. So this is what I mean by when a function invokes another function, eventually resulting in the original function being invoked again. Now, let us have a look at general format of recursive function. Now, this is a general format of recursive function. Have a look at the flowchart or the format very carefully. It can be noticed that the first thing we need to do is to verify that if exit condition is satisfied. If exit condition is not satisfied or is satisfied, then recursion would get halted. On the other hand, if the exit condition is not satisfied, then the body of the functions gets executed once again by transferring the control to the beginning of the function, right? So that's what it is here, right? So you have exit condition satisfied, and if it is true, then it gets stopped. If it is false, right, you know that whenever you use a if condition, the condition should be either true or false. So in case of recursion, if the exit condition is true, so it will stop. If the exit condition is not true, that is, if it is false, then the body of the statements of the functions, the statements which comes in the body of the function that will be executed, again going back to the recursive call, right? So this is actually you mean by a recursive format or a general format of a recursive function. Now let us proceed further, and then let us have a look at one of the important application of recursion, what is called as factorial of a number, right? So let us try to code this and then try to understand how it exactly works. So what I do is I just have a let me have a look at the function declaration later. So I just have two variables, and then I say enter a number whose factorial is to be found, and then I say scanf. I just say A. That's what I want to find out. And then what I'm going to do is I'm going to call a function with A as a parameter, and I call the function name as recfact. So the moment I have a function call, I'll go back top, and then I will declare the function prototype with one parameter, and then I come back here. So I just say factorial of percentage %d is percentage %f. So let me write the definition part of the function. So I have a local variable called as fact, and then what I say is if x equal to 1, if you're trying to find the factorial of 1, so I just say return 1. Otherwise, so what I'll do is I will say fact is equal to x into recfact of x minus 1, right? So this is where you see I am calling the recursion. So first time I called the recursion with x as a parameter. Next time I am calling a recursive call with x minus 1 as a parameter. So that is how I keep on decrementing the close to decrementing the values which will take me to the exit condition step by step. And once I complete this process, I will return the value of fact. Okay, so let me see whether this code works now. Let me compile and run the program for you. So it just says enter a number whose factorial is to be found. So I just say 5 and I press enter key, and it says factorial of 5 is 0. Wow, that's nice. Okay, all right. That's it, right? So I'm getting enter a number whose factorial is to be found. I gave input as 5 and I'm getting output as 120, right? Let me run for one more program and I say 7 and I get the output as 5040. Okay, so this is how basically you write the program for factorial, correct? So you are calling a function recfact in line number 8, right, with a as a parameter. Controls comes here, the value of x will be same as a, and you have a local variable fact. And if you say that x is 1, you just return 1, right? Otherwise you return, actually you calculate fact is equal to x into recfact of x minus 1. So this line number 18, recfact of x minus 1, this is where you are calling the same function which you have written in line number 12. So this is a pure example of recursive call. Okay, so this is how you land up writing a program to find the factorial of a number using recursion. Now let us decompose this particular factorial, recursive function for factorial 3, how actually it works. So I'll just explain you with the help of a flowchart. Of course, nothing great in this. Now, if I am given a task of finding factorial 3, and I'm such a dumb person that I really do not know what is factorial 3, right? So, but the only thing that I know is I know that factorial 3 is nothing but 3 multiplied by factorial 2. So what I do is I go and ask my friend, because that guy is the one who knows factorial 2, and he also does not know anything else actually. So I just go and ask him, hey, what is factorial 2? He says, hey, I'm also not aware of what is factorial 2. But I know that factorial 2 is nothing but 2 multiplied by factorial 1, right? So what he does is, he says that if somebody gives me on this earth factorial 1, I'll just give it to you. I'll just multiply it by 2 and give it to you. So that guy will go and ask for somebody else what is factorial 1. He also tries to give the same statement and says that I do not know factorial 1, but factorial 1 is nothing but 1 multiplied by factorial 0. And if somebody on this earth can give me the factorial 0, I will definitely try to help you out. And then we catch the last person and he says, that's the only thing I know on this earth. And I know that factorial 0 is 1. So he says factorial 0 is 1. He gives to this particular person, who will multiply it by 1 and gives it to this person as 1. So here what happens, factorial 2 is nothing but 2 into 1, which is 2. And then what happens, that 2 is given to me, right? Because I was the person who was interested in finding out factorial 3. And you remember, I said that I don't know factorial 3, but factorial 3 is nothing but 3 multiplied by factorial 2. So the guy whom I relied on factorial 2 gave me the answer as 2. So blindly believing that guy, I just multiplied by 2, I just multiplied 2 with 3 and it gave me 6. And then I draw a conclusion that factorial 3 is nothing but 6. So this is how basically the factorial program works, and as a matter of fact, how actually recursion takes place in programming languages. So let us have a look at the properties of recursion. Recursion actually should satisfy two properties. What I'm trying to say is, as a programmer, whenever you make an attempt to write programs using recursion, you should keep these two properties in mind. The first property is it should always have a stopping condition. Please understand. Otherwise, your code will go to an infinite loop. Now, what do you mean by stopping condition? In the factorial program, if you see, right? See, I was trying to find factorial 3, then it disintegrated into factorial 2, then factorial 1, and then factorial 0, correct? So that is where I draw my conclusion as a stopping condition. Now, if I do not know where I am going to stop, then tell me what's the use of programming? First condition or first property. Second, each time function calls itself, it must be a nearer to the solution, right? Have a look at it. I was trying to call factorial 3, then we went to factorial 2, then factorial 1, factorial 0. We were going close to the solution, right? Now, when you reverse back, factorial 0 was 1, then factorial 1 was 1, factorial 2 was 2. So when I come to factorial 2, I'm just one step away from factorial 3, right? So that is what we say, that each time function calls itself, it must be nearer to the solution. Now, apart from knowing the properties of recursion, there are two important things that we should know. The first one is advantages, and obviously the second one has to be disadvantage. The following are the advantages of recursion. First, it reduces the complexity of the problem. Second, it allows user to write much simpler and more elegant programs. Third, recursion programs will be smaller in length. And fourth, it is top-down programming tool. Let us also have a look at the disadvantages of using recursion. First, recursive solution is always logical and it is very difficult to trace, sometimes difficult to debug and understand. So, that's what it means. Difficult to trace and understand. Second, in recursive, we must have an if statement somewhere to force the function to return without the recursive call being executed. Otherwise, the function will never return. So that's what you have seen in the factorial program, right? If you just try to recollect the statements that we have written in the definition part, we said if x equal to 1, return 1, right? So that if statement was forcing the function to return. Third, recursion takes lot of stack space, usually not considerable when the program is small and running on a PC. Actually speaking, recursion makes use of a data structure called as stack, which you will study in more depth in your higher semester subject called as data structures. But as of now, just understand that recursion actually consumes a lot of space from your stack. And the fourth disadvantage is recursion uses more processor time. Now, let me also show you another example of recursion, that is well-known example of Fibonacci series. Of course, I'm not going to code this and show it to you on the compiler. Just have a look at it. For the benefit of those who are not aware what exactly you mean by Fibonacci series is, it is a series of number where the first two digits are 0 and 1. The first two digits or the first two numbers are called as 0 and 1. Correct? And every next digit or every next number in this Fibonacci series is nothing but the addition of the previous two numbers. I repeat, every next number is nothing but the addition of previous two numbers. So just watch out what I am telling. A couple of numbers in the Fibonacci series from the beginning is 0, 1, then again you will have 1, right? So let me show you here itself. Say for example, the first number is 0, the next number is 1, right? So these are the two numbers of the Fibonacci series. Now this 1 plus 0 is nothing but 1. So I said every next number is the addition of previous two. So the next number will be addition of these two. So 1 plus 1 is 2. The next is addition of these two. So that is 3. Next is addition of these two. That is 5. Right? Then I'll have 8, then I'll have 13, then I will have 21, then I'll have 34, and keep on like this, right? So this is what you mean to say Fibonacci series. So you can just go try to understand this particular code and then try to code it and see, how actually this particular program works. Now, the difference between recursion and iteration, right? One of the most commonly asked question, even in the university examination as well as in the placement, is the difference between recursion and iteration. Most of the people, they just give 2-3 differences between recursion and iteration. But I always feel that whenever you give the difference between these two important tool of programming language, that is recursion and iteration, you should always tell the basic for comparison, right? Just don't land up telling, okay, recursion does this and recursion does that and iteration does this and iteration does that, or this is the difference between recursion and iteration. I always feel you should always have a basic for comparison, the parameter that you are considering for comparison, and then you compare, things will be much more clear in understanding. So the first basic for comparison is the basic itself, right? I'm not going to tell all the stuff that is there. You can just go through the slide which is there, right? So recursion statement in a body calls the function itself, and iteration says set of instructions to be repeatedly executed. So I have another comparison or difference in terms of format. Then I have in terms of termination. I have in terms of condition, right? So iteration says if the control condition in the iteration statement never becomes false, it leads to an infinite iteration, right? On the other hand, recursion will lead to infinite recursion. I have some more basis for comparison. Infinite repetition, recursion, infinite repetition will crash the system. In case of iteration, it uses CPU cycles repeatedly. Then you have applied. Then you have the data structure that we are using. Of course, as I told you earlier, recursion uses stacks. Iteration does not use stack, right? Then you have overhead, you have speed, you have size of the code, right? Recursion is always slow in execution as compared to the iteration. But of course, when you look at the size of the code, right, iteration makes the code much more longer. On the other hand, recursion reduces the size of the code, right? So I have basically used 10 parameters for comparison, right? And that is how I land up differentiating the recursion and iteration. Now, having known all these things as a C programmer, I have $1 million question. Hey, which is better, recursion or iteration? Right from day one, when I started C programming language, I coded a lot of programs using iteration. And now I have been exposed to recursion, looks to be interesting and looks to be better. But then I have now confusion, right? When an application is given to me, should I use iteration or should I use recursion? Now, let me tell you very honestly. If the algorithm solving of the problem is recursive, the implementation of recursive solution can be much more readable and elegant than iterative solution to the same problem. Sometimes defining equivalent algorithm is considerably more difficult, and it is not easy to be proven that the two algorithms are equivalent. Actually, in certain cases, whenever you use recursion, we accomplish more simpler, shorter, and easy to understand solutions. But that may not be the case all the time, actually. On the other hand, recursive calls can consume much more resources in terms of CPU time and memory. On each recursive call in the stack, right? We have seen that the data structure used is stack. So on each recursive call in the stack, new memory is set aside for arguments and local variables, and also for the returning results, right? You remember your factorial program, you said if x equal to 1, return 1, and sometimes you also said return fact, right? So the returning results will also have some sort of memory. If there are too many recursive calls, a stack overflows, right? A stack overflow can happen because it is just lacking memory. In certain situations, the recursive solutions can be much more difficult to understand, and in which case I will recommend to follow the relevant iterative solutions, right? Let me tell you one thing, that even though recursion is a powerful programming technique, I iterate, recursion is a powerful programming technique, but as a programmer, we have to think carefully before using it. If used incorrectly, it can lead to inefficient and tough to understand and maintain solutions. Let me conclude, right? To conclude the concept of recursion, let me tell you, The general conclusion from majority of the problems that has been formulated in the field of programming language, just to name a few, like factorial of a program, Fibonacci series, then you have GCD of two numbers, and then you have lot of applications in algorithms which uses recursion. One of the best example that I like is the Tower of Hanoi problem, which uses recursion. It's just amazing, and I love that problem. That is Tower of Hanoi problem. So what I'm trying to say is the general conclusion from majority of the problem is already formulated. And if you do not know, or if you do not understand how recursion works, let me tell you honestly, avoid using it. Avoid using it. Strong chess players have vast numbers of standard patterns and plans in their long-term memory. As they play a game or analyze the positions, these patterns and plans are accessed, compared, and updated. I have always felt, in my experience, that programming is similar in nature. You can add to your stock of programming patterns and plans by learning the techniques such as recursion. And when it comes to the concept of implementation, recursion is not hard to implement, as majority of the people they say, but in the right circumstances, right? In the right circumstances, definitely believe me, recursion is not hard to implement. It is important to make sure that the algorithm terminates, especially in cases where data corruption may occur. In other words, don't rely on absolute correctness in the incoming data. Also, it may be important to verify that any overhead attached to recursive calls is not too high for your application. And lastly, I would like to tell you that always look for iterative solutions unless you deeply understand how to use recursion. I repeat, unless you deeply understand how to use recursion.